A great day! Dear grade 8 learners, I'm sure that you are excited again for today's episode of Science 8 Quarter 3 Week 3. I am teacher Maryann, your science teacher who will guide you for today's session. Before we proceed, please be reminded again with our science rules dubbed as BTS. B. Be sure that you are in your most comfortable learning environment or conducive learning zone. C. Take down important notes and insights because you need this in your studies. F. Seek assistance from your teachers, parents, household members, and peers in case you need help. These reminders are your guide as we learn trends and explore the wonders of science. If you want to know the reason why, listen attentively to our discussion. Sit back, relax, and take note of the important details about our topic, like playing magnets. Placing both north ends together, these magnets would move away from each other while putting in north and south ends together. These magnets would attract each other. This is because of the notation that unlike attracts and like repels. Considering the fact, electric charges behave similarly. Like charges repel and unlike charges attract or pull toward each other. I'm sure that you are excited to know more about our topic. Listen attentively to our discussion. What do you think composes an atom? When the idea of the atom was conceived, they thought the atom is indivisible, that is, has no parts. From the experiments conducted in the latter part of the 19th century to the early half of the 20th century, they collected evidence that atoms are composed of particles, namely proton, electron, and neutron. These are collectively known as subatomic particles. Protons are the positively charged subatomic particles and are found inside the nucleus. Electrons are the negatively charged subatomic particles and are found outside the nucleus of an atom. Neutrons are the neutrally charged subatomic particles found inside the nucleus. Since it has no charge, this makes the overall charge of the nucleus positive.
Looking on the figure about the history of the atom, theories and models, we can identify now the differences of these particles. John Dalton drew upon the ancient Greek idea of atoms, atomos meaning indivisible. His theory stated that atoms are indivisible. Those of a given elements are identical, and compounds are combination of different types of atoms. J. Thomson discovered electrons in atoms in 1897, for which he won Nobel Prize. He subsequently produced the plum pudding model of the atom. It shows the atom is composed of electrons scattered throughout a spherical cloud of positive charge. Ernest Rutherford fired positive charged alpha particles at a thin sheet of gold foil. Most passed through with little deflection, but some deflected at large angles. This was the positive charge concentrated in the center. The nucleus. Niels Bohr modified Rutherford's model of atom by stating that electrons could not occupy values of energy between the fixed energy levels. Erwin Schrödinger, he stated that electrons do not move in set paths around the nucleus, but in waves. It is impossible to know the exact location of electrons. Instead, we have clouds of probability called orbitals, in which we are more likely to find an electron. The massive part of the atom comes from masses of protons and neutrons. Collectively, the proton and neutron are called nucleons. The nucleons, tightly packed together, form the nucleus in the center of the atom. The number of protons is the same with atoms of a particular element. The number of neutrons may vary. The atomic number is the number of protons in the nucleus. Atoms having the same number of protons but different number of neutrons are called isotopes. The isotopes are identified through their mass number, which is the sum of the number of protons and the number of neutrons in an atom.
This time, let's have a discussion on how to solve for the number of protons, number of electrons, and number of neutrons in a particular atom. Example number 1, how many protons, electrons, and neutrons in sodium atom? Given, element sodium, atomic number of sodium is 11, mass number of sodium is 23. Then the answer, number of protons is equal to 11. Number of electrons, 11. Number of neutrons is 12. The symbol sodium designates an atom of sodium that has a mass number of 23 and an atomic number of 11. The number of protons in an atom of sodium is 11. The number of electrons is also equal to 11. Number of electrons is equal to the number of protons for a neutral atom. The number of neutrons in the nucleus is equal to 12. So A minus B, or 23 minus 11. Example number 2, in an atom of copper, A is equal to 64, that is the mass number. The atomic number is 29, mass number is 64, therefore, number of protons is equal to 29, number of electrons is 29, then the number of neutrons is equal to 35. I'm happy that you enjoyed well in our today's episode. In order to level up your understanding, let's have a comprehension check. Don't worry, dear learners. I will show you and read the questions twice. I will give a 5-second timer after each item to decide your final answer. Are you excited? If so, let's begin. Choose the letter of the best answer. Question number 1. Which of the following particles is not found in the nucleus? A. Proton, B. Neutron, C. Electron, D. Quark. Which of the following particles is not found in the nucleus? A. Proton, B. Neutron, C. Electron, D. Quark. Question number 2. Which of the following statements is not correct? A. The total mass of the protons and neutrons in an atom accounts for most of the mass of the atom. B. Neutrons have a charge equal to that of electrons. C. The electron is the first subatomic particle discovered. D. Electrons are negatively charged. Which of the following statements is not correct? A. The total mass of the protons and neutrons in an atom accounts for most of the mass of the atom. B. Neutrons have a charge equal to that of electrons. C. The electron is the first subatomic particle discovered. D. Electrons are negatively charged. Question number 3. Chromium has a mass number of 52 and atomic number of 24. Solve for number of protons. A. 24, B. 28, C. 52, D. 76. Chromium has a mass number of 52 and atomic number of 24. Solve for number of protons. A. 24, B. 28, C. 52, D. 76. Question number 4. Which of the following contains most of the weight of an atom? A. Proton, B. Electron, C. Neutron, D. Nucleus. Which of the following contains most of the weight of an atom? A. Proton, B. Electron, C. Neutron, D. Nucleus. 5. How do you put electric charge to an object? A. By hanging, B. By biting, C. By cutting, D. By rubbing. How do you put electric charge to an object? A. By hanging, B. By biting, C. By cutting, D. By rubbing. Question number 6. In a bismuth atom, the atomic mass is 209. Atomic number is 83. How many numbers of neutrons does it contain? A. 209, B. 126, C. 83, D. 292. In a bismuth atom, the atomic mass 209. Atomic number is 83. How many numbers of neutrons does it contain? A. 209, B. 126, C. 83, D. 292. Question number 7. In an atom of zinc, the respective numbers of protons, neutrons, and electrons are A. 30, 35, 30, B. 30, 65, 35, C. 30, 65, 35, D. 65, 35, 30. In an atom of zinc, the respective numbers of protons, neutrons, and electrons are A. 30, 35, 30, B. 30, 65, 35, C. 30, 65, 35, D. 65, 35, 30. Question number 8. What did J.J. Thomson contribute to the development of knowledge concerning atoms? A. He discovered the proton. B. He discovered the electron. C. He discovered the neutron. D. He established the existence of positive. What did J.J. Thomson contribute to the development of knowledge concerning atoms? A. He discovered the proton. B. He discovered the electron. C. He discovered the neutron. D. He established the existence of a positive. Question number 9. In a fluorine atom, what is the number of neutrons? A. 29, B. 38, C. 10, D. 9. In a fluorine atom, what is the number of neutrons? A. 29, B. 38, C. 10, D. 9. Question number 10. If an atom has 24 protons and 24 electrons, what is the atomic number of this element? A. 0, B. 24, C. 48, D. 42. If an atom has 24 protons and 24 electrons, what is the atomic number of this element? A. 0, B. 24, C. 48, D. 42. Let's check your answers. Here are the answers of each item. Number 1, C. Number 2, B. Number 3, B. Number 4, C. Number 5, B. Number 6, B. 7, A. 8, D. 9, C. And number 10, B. Very good, grade 8 learners. You've got a perfect 10. Also that electric charges behave similarly. Like charges, positive, positive, negative, negative, repel, and unlike charges, negative, positive, attract or pull toward each other. Again, this is Teacher Maryann saying, in this trying time, we must be protons amid the pandemic. Eliminate the electrons that bring us down but always think and reflect first so that every one of us will become neutrons. See you again in our next episode. Keep safe and stay home.